In geometry, the Hinge theorem says that if two triangles share two side lengths that are equal, then the one with the larger included angle must have the larger third side. So what does that mean? Well, check out these two triangles. In this triangle, we're saying the side length right here is 10, and this side length is 7. Now, similarly, this triangle also has a side length of 10 right here, and this side length is also 7. So they share two of the same side lengths. What the Hinge theorem says is that the one with the larger included angle, so the included angle is right here, the angle between these two sides. The one with the larger included angle must have the longer third side. So for example, let's say this angle was 40 degrees on this first triangle, and let's say this included angle was 70 degrees. What the Hinge theorem says is the one with the larger included angle, so this one, it must have a larger corresponding third side of the triangle. And that should be pretty obvious because the larger the included angle, the wider the angle, the longer this distance has to be to span the distance of that angle. And in an extreme case, we could imagine we maybe have some triangle like this, where this side length is 10, and this one is 7, and this angle is really tiny, like if it was 10 degrees. It should be obvious that this third side right here, it must be very small because this angle is so small. So that's the idea behind the Hinge theorem. The larger the angle, the larger the third side. Now, the converse of the Hinge theorem says that if two triangles share two of the same side lengths, then the one with the larger third side will have the larger included angle. So if this third side, let's say it had a length of like 9, and this third side had a length of, let's call it 6, the included angle right here must be larger than this included angle, because this side length is larger than this side length. So that's the idea behind the Hinge theorem. Let's take a look at a few examples of how to actually use this theorem. All right, let's check out this example. We have triangle ABC where this side length is 4, this side length is 7, and the included angle is 40 degrees. And then we have triangle DEF where, again, it shares the same side length, so a 4 and a 7, but the included angle is 55 degrees on this one. According to the Hinge theorem, which side length should be longer, BC or EF? So because triangle DEF has the larger included angle, that means that the third side, or this EF right here, must be larger than the side of BC right here. So up here, we'll put a greater sign to EF. Side EF must be larger than side BC. All right, let's check out this example. We have triangle ABC where this side length is 7, and this side length is 5, and this third side length is 6. And then triangle DEF, we can see that it shares two of the same side lengths. So it has a 7 and a 5. And we want to know, is angle A, so this angle right here, how does it compare to angle D right here? Well, based on the converse of the Hinge theorem, we said that when two triangles share the same sides, the one with the longer third side should have the larger included angle. So for example, the third side of this triangle has a length of 8, while the third side of this triangle has a length of 6. So because this side is longer, this included angle, this angle right here, should be wider or larger compared to this angle A right here. So we would say that angle D is larger than angle A. All right, let's check out this last example. Here we have two triangles that share a side. So here is the first triangle, right here, and here is the second triangle. And we can see that this side that goes right down the middle right here, they share this side. So we don't know what the length of this side is, but we know that whatever the length is, the two triangles have it in common. So this side length right here is the same for both triangles. And we can also see that this side length right here is the same for both triangles. It has a length of 3. So because they share two of the same side lengths, the Hinge theorem applies here. And what we want to know is, how does side length AB compare to side length BC? So how does this side length compare to this side length? Well, according to the Hinge theorem, when these two triangles share two of the same sides, the one with the larger included angle should have the larger third side. So here we can see that the included angle on this triangle is 48 degrees, while the included angle on this one is 39 degrees. So the one with the larger included angle, this 48 degrees, should have a larger corresponding third side. So AB should be larger than BC. So we'll go ahead and write AB is larger than BC. So those were just a few examples of how to use the Hinge theorem along with its converse.